welcome back. In this example, the given is that M equals 20 kilogram at rest. The object is at rest. So we draw the object. This is the first case, static, no movement, it's at rest, static. This is the normal contact force, and this is the weight acted downwards, equals mg, m equals 20 and g 9.81. The weight is 196.2 Newton. This is the force here, equals 75 Newton. This is the friction force. It's Fs, which is equal to mu n. First, n equal the weight. So the normal contact force equals 196.2 Newton. Then this one, mu Sn equals 75. We can calculate from this mu S because already we have n. So mu S, the coefficient of static friction, multiply 196.2 equals 75. So mu S equals 75 divided by 196.2. So mu S equals 0.38. Remember, the coefficient of friction has no unit. This is in the first case. In the second case, kinetic. Now the force decreases to 60, and this one becomes kinetic friction. So this is Fk, and this is mu k, and this force decreases to 60. The normal contact force is the same, so mu k n equals 60. N is the same, so mu k multiply 196.2 equals 60. So mu k, the coefficient of kinetic friction, equals 60 divided by 196.2. The answer is 0.31. In this example, we have a given, the mass equals 2 kilogram. So the weight equals mg equals 19.62 Newton. Mu s, the static coefficient of friction, 0.3. We need the minimum force to prevent the object to sliding down. Now, what are the forces act on this object? First, we have the weight. It's acted downwards. So this is the weight. We resolve the weight into two components. So this angle is 60. So this component is W cosine 60, and in this direction W sine 60. W sine 60. Resolve it. Now we resolve it the weight. So the weight is resolved. Also, we have the normal contact force. The normal contact force. This is the normal contact force. We need to resolve that force. If we extend this force, so this is the force, and this is the slope. The force is horizontal, and this angle is 60, so also this angle equals 60, corresponding angles. So we resolve also the force into two components. In this direction, we have F cosine 60. In this direction, we have F sine 60. Now we resolve that force. prevent the minimum force to prevent the object sliding down. So the maximum static friction is upwards. So in this direction, because it will be prevent to sliding down, we need the minimum force. So this is mu n, mu s static, maximum static friction force. He said the object is in equilibrium. In equilibrium, it means the resultant force equals 0. It means Fy equals 0 and Fx equals 0. So this is Fx, this is x-axis, and this is y-axis. The sum of forces in y-axis equals 0. So we start from this. Fy equals 0. The forces up equal the forces down. Upward we have here N, so the normal contact force, upward, equals the W cosine 60 plus F sine 60. The second equation is that Fx equals 0. The sum of forces in x-axis equals 0. So the forces right equal the forces left. So F cosine 60 plus mu n equals W sine 60. Now we need to solve that two equations to get F. Okay, we replace n by its value. So we replace n by its value. So F cosine 60 plus mu already it's given, it is 0.3. So we can write this 0.3 multiply n, W cosine 60 plus F sine 60 equals W sine 60. Okay, we rearrange to get F. So F cosine 60 plus 0.3 W cosine 60 plus 0.3 F sine 60 equal W sine 60. What I did, I distribute 0.3. Now we take F common factor from this. So F as a common factor, cosine 60 plus 0.3 sine 60 equals. What we do now, we move this to the other side with this. So change its sign. So it's equals W sine 60 minus 0.3 W cosine 60. From this we can get F. So F minimum equals this value W sine 60 minus 0.3 W cosine 60 all over cosine 60 plus 0.3 sine 60. And then we can use the calculator to get all of this value because W is 19.62. So we replace W by 19.62. 19.62. So we can get the answer of this by using the calculator. The answer is 18.5 Newton. So this is the minimum force keep the object sliding down. Now we need the maximum force to prevent the object, okay, to sliding up. So what will happen? We change the direction of mu Sn because it is sliding up. So Fx equals 0. So it means W, okay, so F cosine 60 equals mu Sn plus W sine 60. So this is the equation in x-axis, but just we replace n by its value. So, and the mu s, it is given, mu s equals 0.3, and replace n by its value. So F cosine 60 equals 0.3 multiply n. W cosine 60 plus F sine 60 plus W sine 60. Distribute 0.3. So F cosine 60 equals 0.3 W cosine 60 plus 0.3 F sine 60 plus W sine 60. We need F, so we move this to the other side, to the left side. So F cosine 60 minus 0.3 F sine 60 equals 0.3 W cosine 60 plus W sine 60. We take F a common factor. Cosine 60 minus 0.3 sine 60 equal 0.3 W cosine 60 plus W sine 60. We divide by this value to get F. This is F maximum, the second case, equals 0.3 W cosine 60 plus W sine 60 divided by cosine 60 minus 0.3 sine 60. Now, W we calculated before, it's 19.62. W is 19.62. So we use the calculator to get this answer. The answer is 82.99 Newton. The last part, we need to calculate N, the normal contact force. Okay. In the first case, F, it was 18.5. In the first case, it was 18.5. In the second case, it was 82.99. We need to calculate N in the first case. In the first case, N equals W cosine 60, W cosine 60, plus F. This is F1, so plus F1 sine 60. So W, it's 19.62 cosine 60 plus F1, which was 18.5 sine 60. Now we can calculate N1. The normal contact force in the first case, it is 25.8 Newton. The normal contact force in the second case, just we replace F by 82. So it is 19.62 cosine 60 plus F2. F2, which was 82.99 sine 60. So N2, the normal contact force in the second case, it's 81.7 Newton. Please enjoy the next video.
So how important is friction? Well, let's say I'm out for a drive. Car tires need friction to grip onto the road. Without it, my car wouldn't be able to turn at all. But that's nothing. Without friction, the bolts holding the wheels on the car wouldn't work. In fact, none of the bolts, screws, or glue on the car would work, and nothing would stop moving or stick to anything else. Even the trees would blow away with the slightest breeze. Friction is everywhere, and without it, nothing would work.